In this video, you will learn about Intelligent Stack, also known as iStack, and how to configure iStack on Huawei CloudEngine S5700 H-series switches. In the Huawei CloudEngine S5700 H-series switch, the control plane is responsible for calculating routes, generating routing entries, and then delivering these entries to the forwarding plane. The forwarding plane handles packet forwarding by receiving, sending, and directing packets based on the routes provided by the control plane or using ARP entries for direct forwarding decisions. To create a stack between two switches, initially, each switch has its own control plane and forwarding plane. In a stack, each switch is known as a stack member. Each stack member will be assigned a unique stack member ID. A stack member ID is used to identify and manage a stack member. When configuring stack, you need to change the stack member ID of the stack member switches. Each stack member is assigned stack priorities. Switch with highest stack priority will become master, while the other one will become standby. You are advised to set the highest stack priority for the switch that is expected to be the stack master. Each stack member has two stack ports, stack port 1 and stack port 2. Stack port 1 of stack member ID 0 should be connected to stack port 2 of stack member ID 1. Stack port 2 of stack member ID 0 should be connected to stack port 1 of stack member ID 1. Note, if you connect stack port 1 of both member switches, then stack will not become up. Similarly, if you connect stack port 2 of both switches, then stack will not become operational. Once stack ports correctly configured and connected, both stack member will assign roles. Ones with highest priority will become the master. Switch with standby role will be controlled by the master switch. That means that their control planes are now merged. Note, both switches will have separate forwarding planes, but they are controlled by the same control plane of the switch having master role. If there is an issue with the master control plane, then control will be shifted to standby control plane, and then standby control plane will become active and it will control the forwarding planes. Note, because each switch has its own forwarding plane, so a high-speed connection is required between the both switches, so that forwarding information can be synchronized between two forwarding planes. Stack cable is high-speed cable which is used to synchronize these forwarding entries between two switches. A dedicated high-speed optical cable can be used between two switches for stacking. Huawei CloudEngine S5700 H24 UM2CC switch contains 24 multi-GE ports, 425 GE ports and 240 GE ports. All these interfaces support stacking features. It means we can use any of these interfaces as stack ports. Note, if we use any of these interfaces as stack ports, then they cannot be used as service ports. Now, let's discuss the example of stacking that we will configure next. On switch 1, we will configure two items. First, we will configure the stack member priority to 200. Second, we will configure stack port 1. On switch 2, we will configure two items. First, we will change the slot ID to 1 and then reboot. Second, we will configure stack interface 2. Note, after changing the slot ID, the new slot ID will work only after rebooting the switch. Note, there is no need to change stack priority on switch 2, as we have already changed the priority of switch 1 to 200. Which is higher than the default stacking priority of 100. So, switch 1 on the left will be the master switch in this case. Now let's configure the stack. On the left side, we have console to switch 1. On the right side, we have console to switch 2. The command, display version, shows the switch model and software version information. Both switches are S5700 H24 UM2CC. The command, display interface brief, shows the interfaces on switch. There are 24 multi-GE interfaces, 425 GE interfaces and 240 GE interfaces. Here we will be using 25 GE 0/0/1 interface as stack interface between two switches. The command, display stack, shows the stack-related information. Both switches have slot ID 0. Both switches have master role. Both switches have default priority of 100. Both switches are of same model. Remember, we will make switch on left console to be the master stack member with ID 0, and switch on right side console to join the stack as member ID 1. Let's change the switch 1 name to be core with capital letter C. Note, after switch 2 join the stack, you will notice the switch 2 name is also core with capital letter C. This is because switch 2 will be controlled by the control plane of switch 1 whose name is core with capital letter C. Let's configure stack port 0/1 on switch 1, where 0 is the slot ID of switch 1 and 1 is the stack port number. Question mark will give multiple options. Here we will enable interface 25GE0/0/1 to be bind to the stack port 0/1. The command port interface 25GE0/0/1 enable. This enable the interface to be used as stack port 0/1. Press Y when asked. Now the port 25GE0/0/1 has been configured to be stack port 0/1 on switch 1. Let's change the stack priority of switch 1 to be 200. This is because we want switch 1 to be master. So we will change its priority to a higher value than the default value, which is 100. Press Y when asked. Now the switch 1 priority has been changed to 200. The command display stack will show that the stack priority of switch 1 has been successfully changed to 200. The command display stack port shows that the stack port 0/1 is physical port 25GE0/0/1, which is currently up. The command display stack peer shows that both peers are down. Note, we have only configured stack port 1. Stack configuration of switch 1 has been completed. Now we need to configure switch 2 to join stack switch 1. The slot ID of switch 2 is 0. This can be checked by the command display stack, as switch 1 slot ID is 0. So we need to change switch 2 slot ID to be other than 0. So we will change the slot ID of switch 2 to be slot ID 1. The command stack slot 0 renumber 1 will change to stack ID to be 1. But in order to implement this change, switch 2 need to be reboot. Reboot the switch using command reboot. Press Y when asked to continue the reboot process. Now, wait until switch 2 gets reboot. Press Enter to get started. After login, we will disable the terminal monitor because we do not want the logs to display on the terminal. The command display stack shows that slot ID is now 1. Previously, it was 0. The command display interface brief shows that all the interfaces are now started with 1. For example, 25GE1/0/1. Similarly, stack port 1 will be 1/1. And stack port 2 will be 1/2. As per the stacking topology, switch 1 stack port 1 will be connected to stack port 2 on switch 2. So we will configure stack port 2 on switch 2. And we will enable port 25GE1/0/1 with stack port 2 on switch 2. Let's configure stack port 1/2 on switch 2 and enable interface 25GE1/0/1. As soon as the stack port 2 on switch 2 is enabled, you will notice that stack port 1 turned up on switch 1 and stack port 2 turned up on switch 2. Now both switches will perform stack negotiation, and switch 2 will learn that switch 1 will be the master due to its higher priority of 200. As a result, switch 2 will reboot to join the stack on switch 1. Let's wait until the switch 2 gets reboot. After reboot, notice that Switch 2 name has been changed to Core with capital letter C. Both switch have the same system name. The command, display stack, on both switches will represent that switch 1 with slot ID 0 is the master switch and having priority 200, while switch 2 with slot ID 1 is the standby with default priority 100. Both switch have been successfully stacked with each other. The command, display stack port, shows the status of stack ports, along with their associated physical ports. This command is used to identify which stack port is connected to which physical port and their statuses, making it helpful for stack troubleshooting. The command, display stack peer, shows the status of peer relationship. For example, stack port 1, on switch having slot member ID 0, has a peer with stack port on switch having slot member ID 1. Stack port 2, on switch having slot member ID 0, has no peer relationship. Similarly, stack port 1, on switch having slot member ID 1, has no peer relationship. And stack port 2, on switch having slot member ID 1, has a peer with stack port on switch having slot member ID 0. Let's identify the exact stack port relationship. First, check the switch with slot member ID 0. On this switch, the stack port 1 has peer relationship with slot member ID 1. Now, you need to check and find the match on stack member ID 1. Here you will find that stack port 2 has peer with slot member ID 0. These two entries represents that stack port 1 on slot member ID 0 is peer with stack port 2 on slot member ID 1. We have successfully identified the stack peer relationship on command line. Let's check the interfaces brief. The command, display interface brief, shows that interfaces status. Multi-GE 0/0/1 to 23 are the interfaces on switch with slot member ID 0. Press spacebar or use Enter key on the keyboard to display for more. Multi-GE 1/0/1 to 24 are the interfaces on switch with slot member ID 1. Notice, on this command line, you have the interfaces for both switch having slot member ID 0 and slot member ID 1. Again, press spacebar or use Enter key on the keyboard to display for more. Notice that 25 GE interfaces are present with both slot ID 0 and slot ID 1. Also, 40 GE interfaces are present with both slot ID 0 and slot ID 1. Similarly, notice that on switch 2 command line you will have the same result. Switch 2 is stacked with switch 1. And both consoles of switch 1 and switch 2 are in actual connected to same control plane of master switch, which is switch 1 having slot ID 0.